Hi everyone, welcome to this module network boundaries. In the first point, we look routers as gateway. The router provides a gateway through which hosts on one network can communicate with hosts on different networks. Each interface on a router is connected to a separate network. The IPv4 address assigned to the interface identifies which local network is connected directly to it. Every host on a network must use the router as a gateway to other networks. Therefore, each host must know the IPv4 address of the router interface connected to the network where the host is attached. This address is known as the default gateway address. It can be either statically configured on the host or received dynamically by DHCP. When a wireless router is configured to be a DHCP server for the local network, it automatically sends the correct interface IPv4 address to the host as the default gateway address. In this manner, all hosts on the network can use that IPv4 address to forward messages to hosts located at the ISP and get access to hosts on the Internet. Wireless routers are usually set to be DHCP server by default. The IPv4 address of the local router interface becomes the default gateway address for the host configuration. The default gateway is provided either statically or by DHCP. When a wireless router is configured a DHCP server, it provides its own interface IPv4 address as the default gateway to DHCP clients. It also provides them with their respectively IPv4 address and subnet mask as shown in the figure. In this case, we can see the router attached to Internet and attached to the HCP client. And default gateway Internet gateway address is the same to default gateway in this client. The next point is router as boundaries between networks. The wireless router acts as a DHCP server for all local hosts attached to it, either by Ethernet cable or wirelessly. These local hosts are referred to as being located on internal or inside network. Most DHCP servers are configured to be assigned private address to the host on the internal network, rather than Internet routable public addresses. This ensures that, by default, the Internet network is not directly accessible from the Internet. The default IPv4 address configured on the local wireless router interface is usually the first host address on that network. Internal hosts must be assigned an address within the same network as the wireless router, either statically configured or through DHCP. When configured as DHCP server, the wireless router provides address in this range. It also provides the subnet mask information at its own interface IPv4 address as the default gateway as shown in the figure. Many ISP also use the DHCP server to provide the IPv4 address to the internet side of the wireless router installed at their customer sites. The network assigned to the internet side of the wireless router is referred to the external or outside network. When a wireless router is connected to the ISP, it acts like a DHCP client to receive the correct external network IPv4 address for the Internet interface. ISP usually provide an Internet routable address, which enables hosts connected to the wireless router to have access to the Internet. The wireless router server has boundaries between the local Internet network and the external interface. In this image, we can see a wireless router is a DHCP server and ISP router. And DHCP server internet private address, DHCP client external public address. Internet private address, IPv4 address, subnet mask, and default gateway. The default gateway is the same in all clients. The subnet mask is the same in all clients. And the IPv4 address is private address is different in any case. In our case, okay. Finish. We click your Check your understanding of network boundaries by choosing the correct answer to the following questions. In the first is for two hosts that are on the same network, which of the following statements are true? Choice 3. Both hosts will have the same MAC address. Both hosts will have different default gateway address. Both hosts will have different IP addresses. Both hosts will have the same default gateway address. Both hosts will have the same IP address. Both hosts will have different MAC addresses. That's right. Hosts will typically always have different MAC address and IP addresses. Remember, MAC is Media Access Control and IP Internet Protocol. However, hosts on the same network will use the same default gateway address. A host on another network will use a different default gateway address. And question 2. For two hosts each on a different network, which of the following statements are true? Both hosts will have the same default gateway address, both hosts will have the same MAC address, and both hosts will have the same IP address, both hosts will have different MAC address, both hosts will have different default gateway address, and both hosts will have different IP addresses. That's right, hosts will typically always have different MAC address and IP addresses. However, hosts on the same network will use the same default gateway address. A host on another network will use a different default gateway address. And the next point is network address translation NAT. And we have a laugh. Wait a second. Okay, packet tracer examine NAT on a wireless router. Objectives: examine NAT configuration on a wireless router. Set up for PCs to connect the wireless routing using DHCP. Examine traffic that crosses the network using NAT. Instruction Part 1. Examine the configuration for accessing external network. Okay. Add one PC and connect it to the wireless router with a Starlink through cable. Okay. One PC. Add one PC and connect it to wireless router with a Starlink through cable. Okay. Here, fast Ethernet and attached to Gigabyte port 1. Wait for all links to turn green before moving on to the next step or click fast forward. On the PC, click Desktop, select IP configuration, click DHCP to enable each device to receive an IP address by the DHCP on the wireless router. Okay, perfect. Note the IP address of the default gateway. Close the IP configuration when done. Navigate to the web browser and enter the IP address of the default gateway in the URL field. Enter the username, admin, and the password. Okay, my default gateway is this. Okay, and click Status menu option in the upper right hand corner. When select, it displays the router sub-menu page. Okay, status. Okay. Scroll down the router page to the Internet connection option. The IP address assigned here is the address assigned by the ISP. Okay, okay, here, okay. Scroll down the router page to the Internet connection option. Okay, Internet connection. The IP address assigned here is the address assigned by the ISP. Okay, the IP address assigned here is the address assigned by the ISP. If no IP address is present, 0.0 appears, close the window, wait for a few seconds and try again. The wireless router is in the process of obtaining an IP address from the ISP DHCP server. The address C here is the address assigned to the Internet port on the wireless router. Is this a private or public address? Is public. And part 2, examine the configuration for accessing the internal network. Click Local Network within the status menu bar. Okay, click Local Network. Okay, click Local Network within the status sub-menu bar. Okay, scroll down to examine the local network information. This is the address assigned to the internal network. Examine the configuration for accessing the internal network. Click Local Network within the status sub-menu bar. Okay, scroll down to examine the local network information. This is the address assigned to the internal network. Okay, network setup. Scroll down further to examine the DHCP server information and range of IP addresses that can be assigned to connect host. And close the wireless router configuration window. Okay, this is my local network. IP address, local, subnet mask, and DHCP server enabled. This is maximum number and the range. IP address range. Okay. Part 3. Connect 3 PCs to the wireless router. Okay, close. And I need, okay. Add 3 more PCs and connect them to the wireless router with a Starlink through cable. Wait for all links light to green before moving on to the next step or click fast forward. Okay. Okay. On HPC, click Desktop, select IP configuration, click DHCP to enable each device to receive an IP address by the DHCP on the wireless router. Close the IP configuration window. Okay, close, close, close. Okay, click Command Prompt to verify each device IP configuration using ipconfig all command. Okay. Note: this device will receive a private address. Private addresses are not able to cross the Internet, therefore NAT translation must occur. Okay, first with PC0, paste. Okay, this is my IPv4 address. This is my next IPv4 in PC1. This is the address for PC2. And this is the address for the PC3. Okay. And part 4, view NAT translation across the wireless router. Enter simulation mode by clicking the simulation tab in the lower right hand corner. The simulation tab is located next to the real time tab and has a stopwatch symbol. View traffic by creating a complex PDU in simulation mode. From the simulation panel, click Show All Known to change visible events to none. Now click Edit Files and under the MISC tab checkmark the box to TCP and HTTP. Close the window. Okay, enter the simulation mode. Simulation mode. Okay, I close these windows and continue. Okay, enter from the simulation panel. Enter simulation mode by clicking the simulation tab. The simulation tab is located view traffic by sending a complex PDU in simulation mode. From the simulation panel, click Show All Known. Okay. To change visible events to none, now click Edit Filters. And under the MISC tab, checkmark the boxes for TCP and HTTP. Okay, MISC, TCP, and HTTP. Close the window. Well done. Add a complex PDU by clicking on the open envelope located in upper menu. Add a complex PDU by clicking on the opened envelope located in upper menu. PDU. Add a complex PDU by clicking on the open envelope located in upper menu. Okay. Click one of the PCs to specify it as the source. Okay. And specify the complex PDU settings by changing the following within the complex PDU window. Under PDU settings, select application should be set to HTTP. Okay. Under PDU settings, by changing the following within the complex PDU. Okay. Select application should be to HTTP. Click Cisco Learn serve to a specific destination device. Okay. For the source port, enter 1000. For the source port, source IP address Okay. The source port enter 1000. Under simulation settings, select periodic enter select periodic enter 120 seconds for the interval. Click Create PDU in the Create Complex PDU window. Periodic Create PDU invalid destination IP address. Okay. HTTP destination device. Okay. Double-click the simulation panel to unlock it from the PT window. This allows you to move the simulation panel to view the entire network topology. Observe the traffic flow by clicking play in the simulation panel. Speed up the animation by sending the play control slide to the right. Now click View Previous Event when the buffer full message is displayed. Okay. Okay. We can see the message travel from PC0 through wireless router and Cisco Learn NAT.com. Okay, part 5 view the header information of the packets that travel across the network. Examine the headers of the packets sent between the PC and the web server. In the simulation panel, double-click the line down in the event list. This displays an envelope in the work area that represents that line. Click the envelope in the work area window to view the packet and header information. Click the envelope in the work area window to view the packet and header information. Click the Inbound PDU Details tab. Examine the packet information for the source IP address and destination IP address. Click the Outbound PDU Details tab. Examine the packet information for the source. Inbound, inbound PDU details. Outbound PDU details. Ethernet. Okay. Okay. Click the inbound. Okay. Well, 100% complete. And okay. Is this a private or public address? So answer public IP address. And finish with gateways to other network summary. What did I learn in this module? Network boundaries. Every host on a network must use the router as a gateway to other networks. Therefore, each host must know the IP4 address of the router interface connected to the network where the host is attached. This address is known as the default gateway address. It can be either statically configured on the host or received dynamically by DHCP. The wireless router acts as a DHCP server for all local hosts attached to it, either by Ethernet cable or wirelessly. These local hosts are referred to as a being located on an Internet or inside network. When a wireless router is connected to the ISP, it acts like a DHCP client to receive the correct external network IP4 address for the Internet interface. ISP usually provide an Internet routable address, which enables hosts connect to the wireless router to have access to the Internet. The wireless router serves as the boundary between the local Internet network and the external Internet. And the next step is NAT operation network address translation. The wireless router receives a public address from the ISP, which allows it to send and receive packets on the internet. It in turn provides private address to local network clients. The process used to convert private address to Internet routable addresses is called NAT. With NAT, a private local source IPv4 address is translated to a public global address. The process is reserved for incoming packets. The wireless router is able to translate many Internet IPv4 addresses to the same public address by using NAT, Network Address Translation. Only packets destined for other networks need to be translated. These packets must pass through the gateway, where the wireless router replaces the private IPv4 address of the source host with its own public IPv4 address. Webster reflection question: It's turned out that the IPv4 address on the device in my home network are private addresses that are only used in my LAN. But if I need to venture out beyond my home network, perhaps to go to the internet, or send an email to someone outside of my network, my device needs to be assigned a public address. How does your router know if you are trying to get access to the device or a website that is outside of your LAN? Or how do you know that your private address has been translated into a public address? And gateways to other network quiz. A computer has to send a packet to destination host. A computer has to send a packet to a destination host in the same LAN. How will the packet be sent? The packet will send to the default gateway first, and then depending on the response from the gateway. No, the packet will be sent directly to the destination host, and the packet will first be sent to the default gateway. The packet will be sent only to the default gateway. Typically, which network device will be used to perform NAT for a corporate environment? Which network device will be used to perform NAT for a corporate environment? A router. Question 3. Which characteristic describe the default gateway of a host computer? The logical address of the router interface on the same network as the host computer. The physical address of the switch interface connected to the host computer. Which characteristic describe the default gateway of the host computer? The physical address of the router. The logical address assigned to the switch interface connected to the router. The physical address, the logical address of the router interface on the same network as the host computer. Okay. Question 4. What is the purpose of configuring a default gateway address on a host? To provide permanent address to a computer, to identify the network to which a computer is connected, to identify the logical address of a network computer and uniquely identify to the rest of the network, to identify the device that allows locate local network computers to communicate with devices on other networks. If the default gateway is configured incorrect on a host, what is the impact on communication? The host is unable to communicate on the local network. The host is unable to communicate with hosts on remote networks. Which three IPv4 address networks address are private IPv4 address. Private. What is the purpose of NAT? Allowing hosts configured with registered public IP address to access the Internet. Translate private IP address to a public registered. Okay. What is the primary advantage of using NAT? Allows a large group of users to share one or more public IP addresses. Allow a large group of users to share the same private IP. Allow the static mapping of public inside. Allows dynamic mapping of registered inside address of private outside. What is the primary advantage of using NAT? Which three settings must be configured on a PC in order for it communicating with the device located across the Internet? Choice 3. The default configuration on a home wireless router provides which type of address to device using DHCP. Which type of intermediary device acts as a boundary between home wireless network and the Internet? Excellent. Congratulations, you have passed the test. Okay, this is all for this module. See you in the next one. Bye.